Think about the smartest, most highly trained data analysts you know.
Yeah.
I mean, the ones working in finance, retail, and tech.
Oh, sure.
You probably picture them doing, deep predictive modeling,
Mhm.
right? Finding those hidden trends that are going to save a company millions.
Right. The really high value work.
Exactly. Well, here is a staggering reality for you.
Mm.
Right now, those brilliant analysts spend 50 to 70% of their time just fielding ad hoc requests.
Yeah, that's just a brutal statistic.
It really is. Welcome to Kanerika's podcast, The Digital Shift. Today, we're exploring a massive transition happening in enterprise technology.
Hmm.
We're looking at the end of the static dashboard era, basically, and the rise of something called Agentic BI. So our goal today is to unpack what this is, why the foundational architecture breaks down so easily, and the impact it's having on modern business operations, pulling from our latest internal content.
And, the scale of this transition, it really cannot be overstated. We are looking at one of the fastest technology shifts in enterprise analytics in a decade, easily.
Really, a decade.
Oh, absolutely. I mean, for years, companies have poured billions into dashboards, essentially creating these passive systems.
Mm.
You just look at them and you try to interpret them.
Right. You have to do the work.
Exactly. What we are moving toward now are active systems, frameworks that can actually think, remember the context of your questions, and crucially take action. It just completely redefines the relationship between a business user and their data.
Well, let's start with that fundamental shift, because for the longest time, the dashboard has been the holy grail, right? Like, you want to know what's happening, look at the dashboard. And if the information isn't there, well, you submit a ticket. But it sounds like the fundamental mechanics of how we get answers are changing.
Right.
So what is the actual mechanism behind Agentic BI? Like, how does it fundamentally differ from just clicking filters on a screen?
Yeah, so the core difference lies in who carries the cognitive load. In traditional business intelligence, the human user does all the heavy lifting. You have a business question, and to get an answer, you have to either navigate this highly complex dashboard interface, hoping the creator actually anticipated your specific question.
Which they rarely do.
Right, exactly. Or you have to translate your business need into a technical ticket. Then you wait for a data analyst to write SQL code, extract the data, and build a static report days later. The whole system is entirely dependent on human translation.
So the bottleneck is essentially the human acting as an interpreter between the business language and the database language.
Precisely the issue. So Agentic BI removes that human bottleneck. Instead of users translating questions to navigate a system, artificial intelligence agents take a natural language request directly from the user.
So I just type it in.
Yeah, you just type your question in plain English. The agent then autonomously scans the available data sources, writes the underlying query, generates a visualization that matches that specific question, and returns the insight. It's a fundamental inversion of the workflow.
That's wild. Our content points to three specific pillars that make this possible: autonomy, context, and action.
Yeah, those are the big three.
The concept of an autonomous agent sounds powerful, but I want to make sure we really understand the mechanics of it. Does autonomy just mean it, like, writes code faster?
No, it goes much deeper than speed. Autonomy means the agent is capable of planning its own approach to a problem.
Okay, how so?
Well, when you give it a complex multi-part question, it doesn't just run a pre-programmed script. The agent actively breaks that question down into subtasks. It evaluates which database tables contain the necessary information, figures out how to join those tables together, and executes a multi-step plan to arrive right at the answer.
Oh, wow.
Yeah, it's reasoning through the how of the problem rather than just waiting for instructions.
That makes me think of an analogy. We are essentially talking about the difference between a paper map and a fully autonomous vehicle.
Ooh, I like that.
Right. Like with traditional BI, the paper map, you know your destination, but you are the one unfolding the map, locating your current position, and manually plotting every single turn.
Yep. And if you hit construction, you have to pull over and recalculate the whole route yourself.
Exactly. The map is static. It just shows you the terrain.
Right. The terrain is the data, and the user is doing all the driving.
But Agentic BI is the autonomous vehicle. You get in, you say, take me to the airport, and the internal mechanics just take over. It calculates the optimal route. It monitors live traffic data. It adjusts for roadblocks in real time. And it physically drives you to the destination.
Yeah.
You didn't need to know the street names. You just needed to know where you wanted to end up.
That's spot on. And expanding on that autonomous vehicle analogy, consider what happens if you change your mind halfway to the airport and say, actually, let's stop for coffee first. The car doesn't demand you restart the entire journey from your driveway, right? It adapts based on where you currently are. And that brings us to the second pillar, context. In Agentic BI, memory persists across your conversation.
How does that memory actually function on a technical level, though? Because in an older system, every query is a blank slate.
Behind the scenes, the system maintains a running log of the conversational thread. It often uses vector databases to map the relationship between your previous questions and the current one.
Okay, so it tracks the history.
Yeah. So if you ask for Q3 revenue, the system retrieves it. If your very next question is, how does that compare to last year? The agent remembers the previous parameters. It knows that that refers to Q3 revenue.
That's incredibly helpful.
It is. You aren't forcing the user to restate the entire premise of their analysis every time they ask a follow-up question. It builds an ongoing analytical narrative.
Okay, so autonomy and context clearly change the user experience. But the third pillar action feels like a massive departure from what BI has historically been.
Oh, it's a huge shift.
Because BI has always been about, well, looking at numbers, generating a chart. What does the action implication actually mean when we talk about automating decisions?
The action layer is the bridge between finding an insight and doing something about it. Good agentic BI connects directly to a company's downstream operational workflows.
Let's define that term for a moment, just so we're clear. When you say downstream operational workflow, what does that look like in practice?
Good question. It means the software and processes that actually run the business day to day. So your inventory management system, your customer relationship management software, your team's communication platform.
Things like Salesforce or Slack.
Exactly. Traditionally, BI lives in isolation. You see a dashboard indicating a supply chain delay, and then a human has to leave the BI tool, open an email, message a supplier, and log into an inventory system to adjust delivery dates.
So the human is still the manual bridge between the insight and the action.
Yes. But with the action layer, the AI agent can be granted permissions to interact with those systems directly within strict, predefined guardrails.
Wait, so the AI does it for you?
Yep. If the agent detects a critical anomaly in stock levels, it doesn't just display a red chart. It can push a high-priority alert to the supply chain team's chat channel. It can even draft and open a ticket in the procurement system to reorder the necessary materials.
Wow.
It takes the first logical step towards solving the problem without waiting for human intervention.
So we are completely closing the loop. It is shifting from, here's a problem, you should go fix it, to, here is a problem, and I have already initiated the standard protocol to resolve it.
Precisely. That leap from displaying data to automating routine operational decisions is what separates passive intelligence from active business management.
I understand the theory, but I have to push back here.
Okay, go for it.
We are dealing with large language models, the same underlying technology that powers the most famous chatbots. And these models are incredibly advanced. They can write complex software code, they can pass the bar exam. But our content frames Agentic BI as an orchestration problem, wrapped in a massive accuracy problem. Why would an AI that can pass a legal exam fail so dramatically at reading a corporate spreadsheet? Why does it need help figuring out what something like revenue means?
It comes down to the fundamental messiness of enterprise data architecture. Passing the bar exam relies on understanding vast amounts of public standardized text.
Right.
Enterprise data is neither public nor standardized. If you ask a large language model to pull revenue from a raw corporate database, it is going to look at the database schema, which is the blueprint of how all the tables and columns are organized. And in that schema, it might find 20 different columns across 5 different tables that all have the word rev or revenue in them.
Oh, because different departments track it differently. You have recognized revenue, booked revenue, gross, net, deferred.
Exactly. And none of those raw database columns explicitly tell the AI which version of revenue the CFO actually wants to see on a Tuesday morning.
Right. That's a huge problem.
Without an intervening layer to provide that explicit business context, the AI just falls back on its generic training. It guesses.
Guessing in enterprise finance is how people get fired.
Definitely. And the statistics on this are incredibly alarming. When researchers run benchmarks on complex enterprise queries, standard AI accuracy drops from about 74.1% on simple single-table questions down to roughly 35% as soon as complexity increases.
Just 35%.
It gets worse. If you attempt raw text to SQL, meaning you ask a plain English question, and let the AI write database code directly against raw tables, the accuracy rate can plunge all the way down to 16%.
Okay, let's linger on that for a second, because 16% accuracy is terrifying.
It's abysmal.
Imagine walking into a boardroom, handing the CEO a projection for the next quarter, and knowing there is an 84% chance the numbers are entirely wrong.
Yeah.
That isn't just unusable, it's actively destructive to a business.
Yeah.
What does that failure actually look like on the screen?
Well, two specific failure modes appear constantly. The first is hallucinated columns.
Hallucinated columns.
Yeah, so the AI model tries to answer your question, looks at the tables, can't find the exact metric you asked for, and simply invents a column name that sounds perfectly logical.
Are you serious?
Oh, yeah. It writes the SQL code, queries a non-existent column, and then hands the user a beautifully formatted, highly confident, completely fabricated chart.
So the AI is essentially saying, I couldn't find the data, so I made it up to be helpful.
Pretty much. The second failure mode is ambiguous metrics. This is the revenue problem we talked about. The AI picks one version of revenue, perhaps the marketing department's definition of pipeline revenue, and presents it to the operations team.
And they don't know the difference.
Right. The number looks realistic, so the user trusts it. Meanwhile, the finance team runs their own query, the AI picks a different column for them, and suddenly you have two executives in a meeting arguing over completely conflicting numbers.
Wow.
And the worst part is, both of them believe the AI gave them the definitive truth.
It completely destroys the concept of a single source of truth. So if the AI is like a brilliant but overly eager waiter who keeps grabbing random ingredients from the kitchen, it sounds like it needs a highly specific menu to order from.
That's a great way to put it.
Our content points to the semantic layer as the solution to the 16% disaster. What is the mechanism of a semantic layer?
Well, your menu analogy is perfect. The semantic layer is a centralized framework that sits between the raw database and the AI agent. It acts as a universal translator.
Okay.
So in the raw database, you might have a cryptic column named TXMGR01.
Very catchy.
Right. The semantic layer maps that specific technical column to the plain English concept of gross transaction amount. And more importantly, it locks in the mathematical formulas.
How does that work?
It mathematically dictates that whenever a user asks for gross margin, the system must calculate it using one exact governed formula approved by finance.
So the AI isn't allowed to guess anymore. It has to route its logic through the semantic layer's rulebook.
Exactly, and the impact on accuracy is staggering. When you force the AI to read from a well-defined semantic layer rather than raw tables, that 16% accuracy rate for text-to-SQL rockets past 90%.
That is a massive jump.
It changes the tool entirely. It goes from a toy into a reliable enterprise asset.
Well, this brings us to a major development mentioned in the material regarding Microsoft. They've introduced something called the MCP server for Power BI. How does this specific piece of technology solve the semantic layer problem?
So MCP stands for Model Context Protocol. Historically, it has been really difficult to safely connect an external AI agent to a company's internal semantic models. What Microsoft has done with the MCP server is create a standardized, secure bridge. It allows AI agents to directly read the carefully crafted semantic models already built inside Power BI.
Oh, I see. So it's exposing the business definitions directly to the agent's logic engine.
The mechanism is super elegant. Before the AI even attempts to write a query, it reads the JSON definitions of the company's metrics through the MCP server.
So it gets the rules up front.
Exactly. The precise governed definition of every business term travels with the query. The AI is restricted to the established rulebook, virtually eliminating those hallucination and ambiguity errors we discussed.
You know, this analytical framework, the absolute necessity of a semantic layer to prevent AI hallucinations, and the drive to connect insight to action without dashboard navigation, this is exactly why we at Kanerika developed our own data insights agent, Carl.
Yes, Carl represents the practical application of this architecture. It is built to operate within complex environments like, Microsoft Fabric, Databricks, and Snowflake, addressing the exact structural challenges we've outlined.
Let's walk through the mechanics of how Carl actually functions for a business user.
Sure.
If I am a regional operations manager, I no longer have a dashboard. How am I interacting with my data?
The interaction model becomes entirely conversational. You ask Carl a question as if you were messaging a colleague. You might say, what are the current inventory levels for the Northeast region, and how does that compare to our Q2 forecasts?
Natural language, just like that.
Yep. Carl processes the natural language, routes it through the semantic layer to ensure he is using the correct definition of forecast, writes the query, and returns a tailored chart.
That's incredible.
And crucially, he also provides a written natural language explanation of what the data shows. And because of that memory context we discussed earlier, you can immediately follow up with, what happens if we shift 15% of our surplus from the south to the northeast? Carl just understands the ongoing scenario.
No SQL, no waiting on the analytics team.
Oh.
But here is the massive roadblock I know enterprise architects are thinking about right now.
Let me guess. Implementation.
Exactly. Implementing a system that in intelligent usually requires a dreaded ETL migration project.
Yes. The 2-year timeline where nothing actually gets done.
Right. And let's quickly define ETL for anyone outside of data engineering. It stands for extract, transform, and load. It is the agonizing process of ripping data out of old systems, cleaning it up, and loading it into a massive new centralized database before you can use any new technology.
It's painful.
It takes months, sometimes years, and millions of dollars. How does an implementation of Carl avoid triggering a massive ETL rip-and-replace project?
The architectural advantage is that Carl is designed to query data in place. He connects directly to where the data already lives.
Wherever it is.
Wherever it is. Whether a company is using traditional SQL databases, NoSQL databases, which, handle unstructured data like documents or social media feeds, or massive cloud data warehouses, Carl interfaces with the existing storage layers. There is no requirement to undergo a massive upfront data centralization project just to make the tool functional.
So you aren't forcing the company to build a new house just so the AI can walk through the front door.
Exactly. The time to value shrinks from months down to days because you are utilizing the existing infrastructure. Furthermore, querying in place solves one of the biggest hurdles in enterprise AI, which is data security.
Right, because the data isn't being copied and sent to an external server to be analyzed.
The data never leaves the client's secure environment. For highly regulated sectors like healthcare managing patient records or finance handling transactional data, this isn't just a nice feature, it is an absolute compliance mandate. The AI comes to the data, not the other way around.
Well, let's look at how this plays out in the real world. Our content highlights a case study involving a UK-based manufacturer that we at Kanerika worked with. What was the specific data challenge this manufacturer was facing before Agentic BI?
So this organization manufactures building products, windows, doors, cladding across multiple geographic sets. Their inventory is in constant motion, and everything is tracked through a Microsoft Navision ERP system.
Okay.
The fundamental issue was the way the ERP structured data. It recorded movements as coded item ledger entries.
I have encountered those ledger entries before. To a warehouse manager or a finance director, they just look like a string of random alphanumeric characters.
Completely.
They're completely unreadable without a technical translator.
Yeah, and the opacity of that data created massive operational bottlenecks. Analyzing variance, understanding why the physical inventory counted on the warehouse floor didn't match the digital inventory in the system was just a nightmare.
I can imagine.
Every time there was a discrepancy, an SQL expert had to manually decode the ledger entries. You routinely had operations managers, warehouse staff, and finance executives sitting in reconciliation meetings, completely disagreeing on which variance numbers were accurate because they were all pulling different ungoverned reports.
It is the exact ambiguous metric problem we discussed earlier. So what was the mechanism of action when Carl was deployed into that chaotic environment?
The first step was establishing the semantic layer. We built a data dictionary framework that translated those cryptic Navision ledger codes into clear, business-readable concepts.
Okay, so laying the foundation.
Exactly. And once Carl was anchored to that semantic model, the warehouse and finance teams could ask natural language questions about the inventory. The impact on their workflow was drastic. They saw a 20 to 30% drop in weekly inventory reconciliation time.
Saving 30% of a finance team's time during a weekly close is a massive operational win.
Huge. They also achieved a 50% reduction in time to insight because users no longer had to submit tickets to the BI team to decode the ledger.
That's amazing.
But the most significant governance win was standardizing over 400 recurring reports. Because everyone was querying the data through Carl, and Carl was strictly following the semantic layer, the warehouse and the finance team were finally looking at the exact same mathematical truth.
You know what stands out to me mechanically in this case study is how Carl handled the variance problem. He didn't just answer questions faster. The system automated the detection of the top 5 to 10 recurring variance patterns.
Yeah.
How does an AI actually flag a root cause like that on its own?
It works by running statistical analyses in the background continuously. Instead of waiting for a human to ask, why are we missing 50 doors? Carl continually clusters similar item ledger entries and analyzes the variance logs.
So it's always watching.
Yep. If it detects that 80% of inventory mismatches occur during a specific type of inter-warehouse transfer, it flags that pattern proactively. It identifies the operational leak rather than just helping the team measure the puddle faster.
It shifts the entire posture of the company from reactive reporting to proactive problem solving. And, this kind of architectural shift clearly isn't isolated to just manufacturing. When we look at the broader landscape, what kind of sector-wide implications is Agentic BI driving?
The content highlights dramatic efficiency gains across multiple verticals. In logistics and supply chain operations, we are seeing Agentic BI drive an average of $1.2 million in annual cost savings simply by optimizing routing and inventory flow autonomously.
1.2 million. Wow.
Yeah. And in highly competitive fields like fintech and health tech, teams are achieving a 50% faster time to market for new products.
How are they speeding it up that much?
Because product managers can analyze user behavior and compliance metrics instantly without waiting for data engineering. And then in the pharmaceutical sector, this capability is contributing to a 30% reduction in project timelines, drastically accelerating how fast research and clinical trial data can be analyzed.
Those metrics represent a fundamental evolution in how corporate strategy is executed. The static dashboard truly is becoming a relic of the past.
It really is. It served its purpose, but the technology has simply outgrown the need for human-driven navigation.
Let's synthesize everything we've covered in this deep dive. We are actively moving away from an era where humans had to manually translate business questions into database code, wait for static dashboards, and manually connect insights to downstream actions. We are entering the era of Agentic BI, systems defined by autonomy, context, and action. But we also established that this future completely collapses into hallucinations and 16% accuracy rates without the absolute bedrock of a semantic layer to govern the AI's logic.
Essential.
Finally, we look at how we at Kanerika are driving this transformation with Carl, querying data securely in place, bypassing the dreaded ETL migration, and fundamentally realigning how teams interact with their data.
Which brings us to the most important implication of this entire technological shift. We began this discussion by pointing out that brilliant data analysts currently spend up to 70% of their time just pulling ad hoc reports.
The routine, repetitive data pulls.
Exactly. If an agentic system powered by a semantic layer takes over all of those routine queries, the role of the data analyst does not vanish. It evolves.
Right, they aren't out of a job.
No, not at all. They move significantly up the value chain, transitioning into data product owners. They become the architects who build the semantic models and design the deep predictive experiments that actually move the needle.
That's a great point.
So the most vital question for the executives and analysts listening is this. If your most talented people suddenly get 70% of their week back, what complex, previously impossible questions are you finally going to let them tackle?
The autonomous vehicle is fueled, programmed, and ready. You just have to decide where you actually want to go. Thank you for joining us for this exploration. Keep questioning your data, keep pushing the boundaries of what your architecture can handle, and we will catch you on the next deep dive on the digital shift.